You have never been outside. Not once. Not for a single second of your entire life. I don't mean outside your house. I don't mean outside the atmosphere. I mean outside the thing that contains everything you have ever seen, touched, measured, or imagined. Every star, every galaxy, every equation we have ever written about the cosmos. All of it inside something. And the most unsettling part is this. The physicists who study black holes for a living, the people who wrote the equations, who built the telescopes, who captured the first actual photograph of a black hole in 2019, they cannot rule it out. Some of them think it is the most logical conclusion the data points to. In the next 30 minutes, I am going to show you 3 real numbers from real physics. 3 measurements that exist in peer-reviewed literature that every cosmologist on Earth knows about. And by the time you see the third one, I promise you the idea that we are living inside a black hole will not sound like science fiction anymore. It will sound like the only explanation that does not require a miracle. Stay with me, because the first number arrives in about 60 seconds. And it will bother you. Here is the number. The Schwarzschild radius of the observable universe, the radius at which all the mass in our observable cosmos would form a black hole if compressed, is approximately 13.8 billion light-years. The actual radius of the observable universe is approximately 13.8 billion light-years. They match. In most textbooks, this is listed as a coincidence, a numerical curiosity, something to note and move past quickly. But a serious, growing group of theoretical physicists has spent decades arguing that it is not a coincidence at all. That you do not get a match like that by accident. That a match like that is a signature. A signature of what is exactly what this video is about. Let's start with what a black hole actually is. Not the mythology. Not the Hollywood version. The physics. A black hole forms when enough mass collapses into a small enough space that the gravitational field becomes inescapable. Not difficult to escape. Inescapable. The boundary where that inescapability begins is called the event horizon. And the event horizon has one property that almost nobody talks about. You cannot feel it. If you were falling into a sufficiently large black hole, the kind anchored at the center of a galaxy, you would cross the event horizon without any sensation at all. No wall, no flash of light, no alarm going off, no sign whatsoever that you had just crossed the most absolute boundary in the known universe. You would keep breathing. Your coffee would still be warm. The molecules in your body would behave exactly as they did a moment before. The event horizon is not a surface. It is a direction. A one-way gate written into the geometry of space-time itself. The only way you would know you had crossed it is if you tried to turn back, and found that every path forward in time also led inward, that there was no such thing as a way anymore. Now hold that image, because I want you to think about the cosmic horizon, the boundary of our observable universe. The edge beyond which light has not had time to reach us in 13.8 billion years. We cannot see beyond it, not because there is nothing there, not because something is blocking it, but because every signal from beyond that boundary is still traveling toward us and has not arrived yet, or never will. It behaves like an event horizon. Information crosses it in one direction. Physics inside it is causally disconnected from physics outside it. We have never detected anything returning from beyond it. We gave it a different name, but the mathematics it obeys is identical. From inside a black hole, you would not see the event horizon. You could calculate where it must be. You could measure its effects, but you could not look at it directly and know it for what it was, because you would be on the wrong side. Think about that carefully. In 1972, a physicist named Jacob Bekenstein did something that made nearly everyone in his field uncomfortable. He suggested that black holes have entropy, Entropy is a measure of disorder of information. And entropy, under the laws of thermodynamics, always increases. Bekenstein looked at black holes and said they must obey this law too. The problem was immediate and obvious. If a black hole has entropy, it must have temperature. But a black hole absorbs everything and emits nothing. It is, by definition, cold. Perfectly, absolutely cold. Stephen Hawking set out to prove Bekenstein wrong. He did the calculation, and instead of proving him wrong, Hawking discovered that black holes radiate. Slowly, invisibly, through a quantum mechanical process that now carries his name. They have temperature, they have entropy, and then came the detail that changed everything. The entropy of a black hole is not stored inside it. It is not proportional to the volume of the interior. It is proportional to the area of the event horizon, the two-dimensional surface. Everything that happens inside, every particle, every interaction, every piece of information about the interior is encoded on the boundary. This is called the holographic principle, and it is not a fringe idea. It is one of the most tested and referenced frameworks in modern theoretical physics. It says, in precise mathematical language, that the interior of a black hole is a projection from its surface. You are three-dimensional. Your coffee cup is three-dimensional. The galaxy above you is three-dimensional. But if we are inside a black hole, if there is an event horizon around us, then everything you experience as solid, three-dimensional reality is a projection from a two-dimensional surface you will never directly see. This is not a metaphor. This is what the mathematics says. And the mathematics has not been proven wrong. The holographic principle tells us the interior of a black hole can contain an entire structured reality, a vast, expanding, cooling universe of its own. What it does not tell us is how that universe began. For that, we need to go somewhere much more uncomfortable. We need to go to the moment before the Big Bang. And what physicists found there is the thing that most textbooks still refuse to say out loud. Let's talk about the Big Bang. Specifically, let's talk about the question the Big Bang does not answer. Where did it come from? The honest answer, the answer every cosmologist will give you if they are being precise, is we do not know. Our equations run backward to within a fraction of a second of the beginning and then stop. The singularity, the point of infinite density at the start, is a mathematical wall. Physics does not describe what is on the other side of it, because physics breaks down at infinite density. But here is what is almost never said directly in popular science. The singularity at the beginning of our universe and the singularity at the center of a black hole are described by the same equations. The same mathematics, the same breakdown. They are not similar. They are identical in form, which means the Big Bang did not look like an explosion from nothing. It looked like the interior of a collapsing object reaching maximum compression and reversing. A bounce, not a beginning, a rebound. This is not a fringe idea. Loop quantum cosmology, a serious, well-funded framework that applies quantum mechanics to spacetime itself, resolves the singularity mathematically and finds exactly this. The universe does not begin. It bounces. There was a collapsing state before. It reached maximum density, and then it reversed into the expansion we call the Big Bang. A collapse that reached maximum density and reversed. That is the precise definition of a black hole in the moments after it forms. Now let's go back to the number I gave you at the beginning, because there are actually 3 numbers, and together they form a pattern that is very hard to dismiss. Number 1. The Schwarzschild radius of the observable universe matches the actual radius of the observable universe to within current measurement precision. You already know this one. Number 2. The density of our observable universe right now is almost exactly equal to what physicists call the critical density. The critical density is the precise threshold at which the universe is perfectly geometrically flat, not collapsing inward, not expanding outward into a curve, just flat. And our universe is flat to within less than 1% uncertainty across billions of light-years of measurement. Flatness that precise, maintained over 13.8 billion years of expansion, is statistically almost impossible under standard cosmological models. It requires the initial conditions to have been tuned to a precision that astrophysicists find deeply uncomfortable. They invented an entire theory, inflation, partly to explain it. But inflation requires its own fine-tuning. Unless flatness is not a coincidence, unless it is a constraint, unless something about the boundary we are inside forces the geometry to be flat, which is exactly what you would expect from the interior of a black hole with a defined event horizon. Number 3. This one is the one that keeps certain physicists awake at night. The arrow of time. Time has a direction. The past is fixed. The future is open. Entropy increases. Eggs do not unscramble. Ice does not reassemble from water. You do not unage. But the fundamental equations of physics are perfectly time-symmetric. Electromagnetism, gravity, quantum mechanics, they all work identically in both directions of time. There is nothing in the laws of physics that prefers the future over the past. The arrow of time is not in the equations. It is in the initial conditions. Our universe began in a state of extraordinarily low entropy, almost impossibly ordered. And from that ordered beginning, entropy has been increasing ever since. The arrow points away from the beginning because the beginning was abnormally neat. But why was the beginning so ordered? Every explanation that does not invoke an external cause simply restates the mystery. It just was is not physics. Random chance at that level of precision is not physics either. But if the beginning was the interior of a collapsing object in a parent universe, if the low entropy of our beginning is the imprint of structure from outside, inherited through the bounce, then the arrow of time has a source, points away from the collapse. It is the direction away from someone else's ending. 3 numbers, 3 measurements, none of them invented, all of them in the published literature. And all 3 of them more consistent with a universe inside a black hole than a universe that appeared from nothing for no reason. You are 3 numbers deep into this now, and we have not even reached the part that gets truly strange. Because those 3 numbers tell us the universe looks like the inside of a black hole. What they do not tell us is where that black hole came from, who or what collapsed to create it, and whether the black holes in our own universe are doing the same thing right now to something else. That is chapter 3. And the physicist who worked it out proposed something so uncomfortable that the mainstream almost refused to engage with it for a decade. In 1992, a theoretical physicist named Lee Smolin published a paper with an idea so structurally strange that most of his peers did not know how to respond to it. He called it cosmological natural selection. And it proposed this: every black hole that forms in our universe does not simply collapse to a singularity and stop. It bounces exactly as loop quantum cosmology predicts, and on the other side of the bounce, a new universe inflates. A daughter universe, born from the collapse of a black hole in a parent universe. The daughter universe inherits the physical constants of its parent, the speed of light, the strength of gravity, the mass of the electron with small random variations, like genetic mutation, like inheritance with noise. And then Smolin asked the evolutionary question: which universes survive to produce the most offspring? The universes that produce the most black holes. Because black holes are how new universes are born. A universe optimized for black hole production is a universe that dominates the next generation. Now here is where it becomes personal. What kind of universe produces the most black holes? A universe with stars. Stars that live long enough to fuse hydrogen into helium, into carbon, into iron. Stars that eventually collapse. You need a universe with the right gravitational constant, the right electromagnetic force, the right nuclear physics, all calibrated precisely enough to let stars form, burn for millions of years, and die and collapse. In other words, a universe fine-tuned for black holes looks almost exactly like a universe fine-tuned for carbon, for chemistry, for biology, for you. Smolin was not claiming consciousness is why the universe exists. He was saying something far more rigorous. He was saying the fine-tuning problem, the question of why the constants are what they are, which has haunted physics for decades, has a natural selection answer. We are not in a special universe. We are in a universe that won, that produced more offspring than its competitors, that was selected for over vast numbers of generations because it was good at making black holes. And every time a star in our universe collapses, every time a black hole forms anywhere in the Milky Way, anywhere in the visible cosmos, a new universe may be opening on the other side. Right now, while you are watching this video, a new Big Bang, a new 13.8 billion year story, a new arrow of time pointing away from a new collapse. The stars you see at night are not just nuclear furnaces. Under this framework, they are parents. Each one that collapses past its Schwarzschild threshold is potentially opening a door that neither we nor anything in our universe will ever be able to see through. Smolin's hypothesis has a property that most ideas in cosmology do not have. It is falsifiable. He made specific predictions about the range of physical constants that should be possible if cosmological natural selection is true. If any of those constants were found to be significantly outside his predicted range, the hypothesis would be dead. As of today, none of his predictions have been falsified. The mainstream is still uncomfortable with the idea, but uncomfortable and wrong are not the same thing. Think about this for a moment. If Smolin is right, even partially right, then the black hole at the center of the Milky Way, Sagittarius A, which we photographed in 2022, is not just an object of scientific curiosity. It is a nursery. It has already created something that will never know we exist. Something that may develop its own physics, its own chemistry, its own version of whatever we are. You share a universe with something that is already giving birth to another universe. And you will never know what that universe becomes. That is not a small thought. Sit with it for a second. Smolin's framework answers where the black hole came from and why the constants are what they are. But there is one thing it does not answer. And it is the thing that makes this hypothesis philosophically dangerous rather than just scientifically interesting. Because if we are inside a black hole, if there is an event horizon surrounding everything we will ever know, then what does it mean that we can almost see it? That we have instruments sensitive enough to detect its signature? And what does it mean that the signature we detect looks exactly like something else we have been trying to explain for 30 years? That is chapter 4. And this is where cosmology meets the thing physicists call the greatest unsolved problem in all of physics. There are two things in modern cosmology that no one can fully explain, and they make up 95% of everything: dark matter and dark energy. Dark matter is the invisible scaffolding that holds galaxies together. We know it is there because without it, the outer arms of galaxies rotate too fast. The math does not work without additional mass that we cannot see, cannot detect directly, and cannot account for with any particle we have yet discovered. It makes up approximately 27% of the total energy content of the universe. Dark energy is stranger. It is the force, if force is even the right word, that is causing the expansion of the universe to accelerate. Not just expand, accelerate. The galaxies are not just moving apart. They are moving apart faster and faster. Something is pushing them. Something that fills all of space uniformly, that does not dilute as the universe grows, that accounts for approximately 68% of the total energy content of everything. We have no idea what it is. The standard explanation calls it the cosmological constant. Einstein introduced it. He later called it his greatest blunder. Modern cosmology brought it back because the observations demanded it. but explaining why it has the value it has, why it is not zero, why it is not enormous, why it is the precise small positive value that allows galaxies to form before the expansion tears everything apart, is a problem so difficult that some physicists call it the worst prediction in the history of science. Quantum field theory predicts a vacuum energy, the energy of empty space, that is 10 to the power of 120 times larger than the observed value of dark energy. That is not a small discrepancy. That is the largest discrepancy between theory and observation in the history of physics, by an enormous margin. Now here is what several serious physicists have proposed, and what I want you to hold in your mind carefully. If we are inside a black hole, if there is an event horizon surrounding the observable universe, then the accelerating expansion we observe as dark energy could be understood as the pressure of the interior of the black hole against its own boundary. The universe is not being pushed by a mysterious energy from nowhere. It is behaving exactly the way the interior of a collapsing and then expanding black hole would behave as the horizon stabilizes and the interior settles. And dark matter, the invisible mass that holds galaxies together without interacting with light, has been proposed by physicists including Nikodym Poplawski to be a signature of the parent universe's physics bleeding through the boundary. Not particles in our universe at all, but gravitational influence from structure on the other side of the horizon. Influence that we can measure by its effects but will never be able to directly observe because it exists in a causally disconnected region. These are not the mainstream explanations for dark matter and dark energy. The mainstream does not yet have explanations that work. These are proposals, serious, mathematically grounded proposals from physicists with real credentials. But here is what I want you to notice. The two biggest unsolved mysteries in cosmology, the things that make up 95% of everything and that no one can account for, both have natural candidate explanations under the black hole universe hypothesis. Not perfect explanations, not proven ones, but explanations that fit the data as well as anything else currently on the table. And they emerge from the same single framework, rather than requiring two separate new theories. One hypothesis, two mysteries, both addressed. In science, when a single framework resolves multiple independent anomalies simultaneously, that is not nothing. That is what a correct theory looks like before the proof arrives. Everything you cannot see in the night sky, the dark matter threading through the galaxies, the dark energy pushing them apart, might be the shadow and the pressure of the thing that contains you, the boundary of your universe pressing in, the parent making itself felt through the only channel still open. You cannot see dark matter. You cannot see dark energy. You cannot see the event horizon. But you are surrounded by all three. And right now, the most honest answer physics can give you is that it does not know what any of them are. Dark matter and dark energy are the data we cannot explain. The event horizon is the boundary we cannot see. The bounce is the beginning we cannot remember. All of it points in the same direction. But there is one final question this framework raises that is not a physics question at all. It is the question underneath the physics. The question that the equations gesture at but cannot answer. And it is the most important question this video contains. That is Chapter 5. Let me be honest with you about what science actually knows. We cannot currently make an observation that proves we are inside a black hole. The hypothesis is consistent with the data. It resolves anomalies that competing frameworks do not resolve. It makes falsifiable predictions, but it has not been proven, and any honest account of it has to say that clearly. What I want to do in this final chapter is not oversell the certainty. I want to do something more interesting. I want to ask what it would mean if it is true, because the implications are not just scientific. They are the kind of thing that changes how a person relates to the sky above them, and to their own existence. If we are inside a black hole, then there is a parent universe. Something that existed before our Big Bang. something that collapsed, a star, a cloud of mass, something, and in that collapse created us. We are not the origin of the story. We are a chapter in a story that started before us, in a universe we will never access, written in physics we may never fully know. We are the aftermath of someone else's ending. And if Smolin is right, if the black holes in our universe are each seeding new universes of their own, then we are also a middle chapter. Not the beginning, not the end. A link in a chain that may be infinite in both directions. Every collapse anywhere in our cosmos is potentially a new beginning somewhere else. Every death is a birth that we cannot witness. The universe is not a closed room. It is a corridor. Now here is the part that I think is the most quietly extraordinary conclusion in all of this. The history of cosmology is a history of boundaries dissolving. The Earth was the center, then it was not. The Sun was the center, then it was not. The Milky Way was the entire universe, then it was one of 2 trillion. Our universe was the only thing that existed, and that may be the next boundary to go. Every time a boundary dissolved, human beings had to rebuild their sense of where they stood. And every time, without exception, the rebuilt version was larger, stranger, and more astonishing than the one it replaced. This is not a smaller universe. It is a universe nested inside something larger, which is nested inside something larger still, which may be infinite in exactly the same way a fractal is infinite. Not bigger than you can imagine. Bigger than imagination is a tool for. And right now, the atoms in your body, forged in stars that collapsed, in a universe that may itself have collapsed into existence from something before it, are sitting inside whatever you are sitting on a planet orbiting a star that will one day collapse, possibly seeding a universe that will never know your name. You are not a spectator of this process. You are made of it. I want to leave you with one image, not a diagram, not a number, just a thought. Tonight, if you can, go somewhere dark enough to see the stars. Look up. Every point of light you can see is a star. Many of them will end in collapse. Each collapse under this framework is a new universe opening on the other side. A new arrow of time. A new 13.8 billion year story. A new version of whatever we are, starting from the beginning, not knowing they are starting from someone else's ending. The universe does not experience itself from outside. It never has. It looks out from inside the only perspective it will ever have. And inside that perspective, against all probability, something developed that looks back. That is what you are. Something that the universe built, possibly from the ruins of a prior universe that turned around and started asking where it came from. That question may never have a final answer. But the fact that you are asking it, that is not nothing. That might be the most remarkable thing in any universe. Now I want to hear from you. And I mean something specific. Most physicists who know this data will tell you it is a remarkable coincidence and nothing more. That the matching numbers are numerical accidents. That the Big Bang was a beginning, not a bounce. That dark energy is a constant, not a pressure. I want to know if you believe them, because the data does not obviously support that level of confidence. And I think if you have watched this video carefully, you feel that tension too. Tell me in the comments. Do you think we are inside a black hole, yes or no, and tell me exactly why. If you think the hypothesis is wrong, tell me which number you can explain away and how. If you think the physicists dismissing it are right, make the case. I read every comment on this channel. I respond to the ones that push back the hardest. The best comment this week, the one with the most rigorous argument for or against, I will pin and respond to personally. If this video made the sky feel different to you, share it with one person. Not for the numbers, for the person in your life who looks up sometimes and needs to know the looking up is justified. This channel exists for a specific kind of person. Someone who cannot hear an answer without immediately needing to know what is underneath it. Someone for whom we don't know yet is the most exciting sentence in any language. Someone who finds the size of everything more thrilling than terrifying. If that is you, you already know what to do. New videos go up every week. The next one goes somewhere just as deep. Until then, you know where I'll be.